with the next example, we now have the function e to the opposite of x squared, and we're asked to find the Maclaurin series for that, which means it's centered at x equals 0. And we're looking to have the first, was it 4 terms, as well as the general term of the series. So let's see if we can figure that out. Now this one takes out a little bit more work than the last one because we have to take the derivative of e to the opposite of x squared multiple times. Now the first time that we derive it, it's not so bad. It's just a quick little chain rule. But it produces a product, and so from every point onward, we have one or more product rules in each iteration of the derivative. All right, so I've actually done the derivatives out here to an extent. When we derive the opposite of 2x e to the opposite of x squared, again, we're doing the product rule. That gives us our second derivative. Now, this term will derive to, again, using just the chain rule, will derive to 4x e to the opposite of x squared. And this term, when we derive it, we need to use the product rule. And the product rule produces 2 terms. And it turns out that the first term that it produces can get combined with our initial term, since we have x e to the opposite of x squared. So that's a total of 12 of them. And then we have our final term, which cannot be combined with everything. When we derive the third derivative, product rule here, product rule there, which means we have 4 parts to our fourth derivative. And we can actually combine the middle 2 parts. They're both 24 x squareds, and they're negative, so we can combine it to negative 48 x squared. All right, when we get to the fifth derivative, well, this does not require a product rule, but these two do require a product rule, which means we're looking at 5 terms. The first term is right there, and then I derive the second term. I did not bother to derive this term because it's not going to be part of the answer when we plug in 0. But there is more to the derivative than what you see on the board. And then when we get to the next iteration of the derivative, again, just drove the first couple of parts because I'm really keen in on that 120 coefficient there. Why is that the case? Because remember, it's not just about finding the derivative, it's finding the derivative and evaluating it at the center of the series. And the series is centered at x equals 0 because we're told it's a Maclaurin. So we actually want f of 0, which we know e to the 0 happens to be 1. When we want f prime of 0, well, that's 0 times 1. When we want the second derivative evaluated at 0, well, this now produces negative 2, and this produces 0, so we have negative 2. When we want the third derivative at 0, right, well, this term produces a 0, and this term produces a 0, so the third derivative will be 0. And we can see a sort of a pattern happening here. The first derivative and the third derivative were both zeros. If we jump quickly to the fifth derivative, notice that the x's are going to cause the fifth derivative of f to be equal to 0 as well when x is 0. Right? Well, how about the fourth and the sixth? Well, with the fourth derivative, this term right here will simplify to 12. The other terms will go to 0. So the fourth derivative of f at 0 is 12. And the the sixth derivative of f at 0 will be negative 120. All right. Now, why do we have to go that far? Why do we have to go to the sixth derivative? Because the question asks for the first 4 non-zero terms. Right? So these 0 coefficients are going to produce terms that go to 0. We don't want that. We just want the non-zero terms, okay, which are the coefficients that are not 0. So let's put it all together. We have Maclaurin here, but we'll call it Taylor. All right, it's our f of 0, 1, plus, and then f prime of 0 times x. But we don't have to write that in. 0 times x is just 0. There's no reason to write that. So we can now go to our quadratic term, rather, right here. We see that the coefficient is negative 2. So we have negative 2 over 2, because remember, this is f double prime of 0. So we have to divide that coefficient by 2 factorial. Hence the reason for this 2 right here. And then we're going to have x squared. Okay. Now we go to the cubic term, but that will have a coefficient of 0, so there is no cubic term. Now we go to the fourth derivative, and when we do so, we see 12. So we will have 12 in the numerator, and we're going to have 4 factorial in the denominator, because this is x to the 4th power. That's 3 terms, but we're asked to find the first 4 terms. So we can see right here that our fourth term will have a coefficient of negative 120. So minus 120 over 6 factorial times x to the 6th. And we're going to add on from there. Okay. Now this can be simplified. We have 1 and then we have minus x squared, and then plus, well, 24 is the same thing as 4 factorial, so that will be x to the 4th over 2. All right, and then 6 factorial is 720, so the 120 and the 720 cancel out to leaving us with 6. So we have here minus x to the 6th over 6 plus more and more terms there. So now, if you could guess as to what the next term might be, do you have any thoughts in that? Well, you're probably guessing that it's going to be x to the 8th. Should it be positive or negative? Yeah, it should be positive. So if we were to put in another term here, we would have x to the 8th, all right, because we see the alternating negative, positive, negative, positive. Now what about our denominator? Any thoughts there? Well, the first denominator was 1, and then we had 2, and then we had 6. So we multiplied by 2, then we multiplied by 3. Perhaps we're going to multiply by 4 now for a denominator of 24. Okay. So what is our nth term then? In regards to the general term, you can have multiple methods of actually expressing the general term. It doesn't have to be simplified. If we're looking at this, let me just get a different color here. We have, in essence, our 0 term and our first term, our second term, our third term, and our fourth term. All right, so in looking at that, if we want our general term, our x to the nth term, our nth term, if you will, I'm just going to get green here. So if we want our nth term, okay, so we can see that we're looking for a situation where it's going to be a fraction, okay, and we see for the first term it was x squared, for the second term it was x to the 4th, for the third term it was x to the 6th. So we actually want x to be raised to the 2n power. All right, and that is going to allow us to have the appropriate exponent. Now, in addition to that, we notice that we are alternating. All right, so that's going to require the -1 to the nth power. So for -1 to the first power, we get a negative term, and for -1 cubed, we also have a negative term. So that's our alternating part. Now we need our derivative. Our denominator. So the denominator for 2 was 2, the denominator for 3 was 6, the denominator for the fourth term was 24, so that seems to be our n factorial. All right, so that situation right there is going to be, or that term right there rather, will be our nth term for the series.